Okay, so for today's lesson, we're going to learn how to solve linear and quadratic equations. The do now is something that's old. Just factor this by I am. So things that add to -5, but yet at the same time multiply to +6 is x minus 3 times x minus 2. Don't forget to drop your wall. Set each factor equal to 0. And then when you solve each equation, your answers are x equals 3 and x equals 2. Okay, so what we're really going to be doing right now is dealing with linear and quadratic systems. A linear is going to be the graph of a line, and a quadratic is the graph of a parabola. And we're going to be looking for the intersection of both of those graphs. A solution to a linear and quadratic pair may consist of either 2 points, 1 point, or 0 points. So what would happen is if you had 2 points of intersection, you might have a line that intersects your parabola like this. So these are your 2 points of intersection. If the parabola intersects the graph in 1 point, it might be something that looks like this. This is going to be your 1 point of intersection. And there's a good chance that your parabola and your line will never intersect at all. And that would be the 0 points. What we're going to do mostly in this class is we're going to graph systems whose solutions have 2 points. Okay, so in order to solve a linear and quadratic graphically, you want to draw the graphs of both equations on the same coordinate plane. When graphing the quadratic, you want to create a table of values that's always going to be centered around the vertex. And the equation to find the axis of symmetry, it's going to be x equals negative b divided by 2a, and you're going to be able to plug in to get your y value. You want to find the common points of intersection by reading the points on the graph, on the two graphs. You can also check your solutions on the calculator. You do it by doing second trace, intersect, and you hit enter 3 times. There's going to be 2 different points of intersection, so you got to find both of them. And as always, your solutions are written as ordered pairs. So this first one, I know that when you use the x equals negative b over 2a to find the vertex, it's actually going to be kind of tricky because your ordered pair or your vertex is like a fraction. So what we're going to do here is for this first equation, we will kind of pull this out anyway. And if you're a little bit confused, no worries, because it'll get much easier. So x equals negative b over 2a. You need to realize that your b is 1 and your a is 1. So when you plug this into your formula, you get negative b over 2a, or negative 1 over 2 times 1. What comes out when you do the math is negative 1/2. So then the x-coordinate of your vertex is negative 1/2. In order to find the y-coordinate of your vertex, and you plug in that value of negative 1/2, getting a little lot, here we go. So you're going to plug in negative 1/2, negative 1/2. And then if you do the math, you're going to get negative 1/2 squared equals 1/4 plus negative 1/2 minus 2. If you put everything in terms of decimals, let's see if I can move this thing up. Yep, so if we move this thing up, we're going to get y equals, I'm going to get this thing moved up a little bit. Extend page. Extend page. There we go. Nice job. So I'm going to get y equals 0.25 minus 0.50 minus 2. And that comes out to be 25 cents minus 50 cents is negative 25 cents. And negative 25 cents minus 2 is negative $2.25. So your vertex ends up being, when x equals negative 1/2, y becomes negative 2.25. Pretty hard to plot. But when we get ourselves a table of values and we center it around this vertex, negative 1/2, negative 2.25, we're just going to go right to the calculators over here, and we're going to get to our calculator right here, and then we're going to type in the equation. So the equation, and if you go into y equals, we're going to type in, what's the equation? So x squared, and then plus x and then minus 2. We'll take a quick look at our graph. We're going to hit graph, and we'll take a quick look at our graph. And then here's our parabola. And then we're going to go to our table of values. So we're going to go to second graph. And we're going to try to find this vertex. So we need to get -0.5 and -2.25. But right now, our table of values is not lining up for us so well. So what we're going to do is pull out some other points if we can. If you look at the calculator, you can kind of see here in the center. I don't think I'm going to be able to draw on it, but in the center, there are some points where it actually go around the vertex. So let me do something real fast. Let me change the table of values. Let me make this at -0.5 to start. -0.5, and go back to the table of values, and we should be able to see our vertex. And there's the vertex right here, smack in the center. Okay, so we've got our vertex right here, and then we've got points on the other side of it. We want to actually plot some points that are ones that we can plot. So I'm going to go back to the table of values for 1 second. Just going to change this back to 1, go back, and pull out a couple of other points. So I think what points might make sense to plot would be these guys right here, which would be -2, 0, -1, -2, 0, -2, and 1, 0. So we're going to plot that on our graph. So with this parabola, what we're getting here is -2, 0. We're getting -1, -2, -1.5, and this is going to be hard to do. -0.5, -2.25, 0, -2, and 1, 0. And we're going to draw our parabola. When we do our line, and we'll do that in red, we're going to begin our graph at +1, down and over to the right one, draw that grid, draw that line. There's 2 points of intersection, so the idea is to figure out what those 2 points are. So here we go back to the calculator. And what we're going to do is go back to y equals, and in y2 you're going to type in -x + 1, and then we're going to graph. And there's the line. So in order to find the 2 points of intersection, we need to calculate those points. So that's where we're going to go second trace, choice 5. And we're going to hit enter not once, enter not twice, but enter 3 times. And it's going to tell you that the first point of intersection, the point on the right, is going to be 1, 0. So we know that one of our solutions is 1, 0. And to get the other solution, we're going to go back and do the same thing. Second trace intersect, which is choice 5. We're going to use the left arrow to move our cursor away from that first point. Hit enter 3 times. And the second point of intersection is going to be -3, 4. Okay, so you can do stuff on the calculator as well as you're going to do stuff on the graph. Let's try this next one. These next one, I don't think these points are as crazy on this next one. Whoopsie. Okay, so if we graph this line first, this line right here, if you subtract x on both sides, you get y equals -x + 5. We begin the graph at +5, down 1 over 1, down 1 over 1. There's our graph. For the parabola, I think this vertex is going to be a big one. Let's see. If x equals -b over 2a, it's going to equal -6 over 2, which means x equals 3. If we now try to get our vertex for y, we've got 3 squared minus 6 times 3 plus 9, which equals 9 minus 18 plus 9. So the y coordinate here is going to be y equals 0. So this is actually much nicer. So now, if we go to our xy chart, we're going to graph, or we're going to center the parabola around this particular vertex, which is going to be 3, 0. We're going to go back to the calculator. We're going to go back to y equals, and we're going to clear out all the old stuff. Hit it again. And then you're going to clear out both of those things in each. Hit clear. I've got a helper today, by the way. My daughter Olivia is here. She's helping me with the graph. So arrow down, clear out this one. Clear it out. Okay. And back in y1, we're going to type in the equation. It's going to be x squared minus 6x plus 9. We'll take a look at the graph. And this is the parabola that we have to graph. So when we go to our table of values and we find the vertex, we know it was centered around 3, 0. So we're going to line up the y values. And there we go. So here's our vertex. And we'll use the points on either side of it. So we're going to graph then 1, 4, 2, 1, 3, 0 we already have, 4, 1, and 5, 4. So 1, 4 is right here. Then we're going to 2, 1. And then we're going to 3, 0, 4, 1. We got it here. So now we need to find these 2 points of intersection, which are right this guy and this guy. So we'll go back to the calculator. And then we're going to go back to y equals. In y2, we're going to type in the equation for the line negative x plus 5 plus 5. And then we'll take a look at this. And now we'll do the second trace intersect. So second trace, choice 5, enter, enter, enter. So one of the order pairs is 1, 4. We'll do it again. Second trace intersect. We're going to move the vertex away. Enter, enter, enter. And the other point is 4, 1. So the points of intersection here are 1, 4 and 4, 1. Nope, got 2 more to go, but we're almost done. Next one. Graph the line y equals x plus 2. Begin at positive 2, up 1 over 1, up 1 over 1. There's your line. We'll actually do the rest of this right on the graphing calculator. So I'm going to go to the calculator, and we're going to go to y equals. We're going to clear out all the old. Type in the new. This one, 2x squared plus 3. Take a look at that graph. We're going to find the points to plot. If we can find the vertex looks like it's over here at 0, 3. So we're going to plot in these couple of points. So for this particular one, we're going to type in negative 1, 5, 0, 3, positive 1, 5. So negative 1, 5, 0, 3, positive 1, 5. And there is no solution here because these things do not intersect. So this intersection is no solution. Got one more to go and then all is done. We have one more to go. Get rid of that, Ollie. Okay, so let's leave it alone, Liv. Stop. Okay, sorry. It's my daughter, like I said. She's in here messing around. Okay, so the last one, y equals x plus 1. Begin at 1, up 1 over 1, up 1 over 1. Graph your line. For this particular quadratic, what? Nope, because I'm almost done. So then we're going to go to y equals, and we're going to type in x squared plus 1. And we're going to graph it. We're going to pull out our table of values. We're going to try to find that vertex, which looks like it's right here at 0, 1. So we're going to take the points around it, and we're going to plot, in this case, negative 2, negative 2, 5, negative 1, 2, 0, 1, 1, 2, 2, 5, negative 2, 5, negative. I don't know what you did. So negative 2, 5, negative 1, 2, 0, 1, 1, 2, 2, 5. And there are 2 points of intersection again. We'll double check on the calculator. And then we will call it a day. So we've got x plus 1 on the second thing. Second trace, intersect, enter, enter, enter. So one of the ordered pairs is 0, 1. Do it again. Second trace, intersect, move your vertex, enter, enter, enter. And the second order pair is 1, 2. So 0, 1, and 1, 2. Okay, so that's it. So you should be able to graph these things by hand, and you should be able to use the calculator to finish the rest of the homework. All right, good luck.